In this video, we're going to continue practicing solving a system of equations using elimination. Since this is our third example, we're going to start to get into some more difficult problems. I'm actually going to do this problem twice all the way through. The first time, I'm going to show you how to cancel out the x's, and the second time, I'm going to show you how to cancel out the y's. That won't always be the easiest thing to do for every system of equations problem with elimination, but for this one, it's actually pretty straightforward for both of them. So I wanted to show you how it would work, and either one that you choose, it's totally up to you. I just wanted to show you how they will both work. So first, we're going to do the x's. So remember, in elimination, we are trying to get rid of either all of the x's or all of the y's. And to do that, we need to have that same number out front, but those numbers need to be opposite signs. Right now, that is not true of either our x's or our y's, so we need to make it true. So I'm going to focus on the x's. I have a 3x and I have a 9x. For me, it would be easier to turn that 3 into a 9. I can do that by multiplying 3 times 3. 3 times 3 gets me 9. I want this, however, to be a negative 3. Or excuse me, I want it to be a negative 9, so I need to multiply by negative 3, because remember, I want to end up with a negative x and a positive x so that they cancel. So if I want to multiply negative 3x by negative 3 to get me negative 9x, I have to do the same thing to the entire equation. So I'm going to rewrite this equation after we do our multiplication. So first, I'm going to do negative 3 times 3x. That gets me negative 9x. Then I do negative 3 times y. That gets me minus 3y. And negative 3 times 6 gets me negative 18. I don't have to do anything to my second equation, so I'm just going to rewrite it how it was. 9x minus 5y equals negative 6. Now I have x's that can cancel out because they have the same number out front, but opposite signs. So I'm going to go ahead and get rid of my x's, and now I can start combining my y's. Negative 3y minus 5y gets me negative 8y. Negative 18 minus 6 gets me negative 24. And then to finish off the equation, I got to get y all alone. So I'm going to divide by negative 8. So that cancels out. Same thing on both sides, so I'm going to end up with y equals 3. So then, in order to find my x, first I'm going to start by writing my answer. Remember, it's got to be an ordered pair, so I just figured out y equals 3. So I can use that information to then go back, plug that into either of my original equations, doesn't matter which one, to find my x. So I'm going to use that first equation, 3x plus y equals 6. But now instead of y, I'm going to rewrite it with 3 in place of y. So I have 3x plus 3 equals 6. Now I'm going to start moving things to the other side to get x by itself. So I'm going to do opposite operations. First I subtract by 3 on both sides. I'm left with 3x equals 3. And I divide by 3, and I'm left with x equals 1. So our answer is 1, 3, or x equals 1 and y equals 3. So like I said, I'm going to do this again, but this time cancel out the y's. So I'll write our answer that we got up here to make sure that we end up with the same answer doing it the second way. Okay. Get this all cleared away. So it's going to be the same process, but this time we're going to focus on the y's instead of the x's. Okay, so when I look at my y's, I have a positive 1y and a negative 5y. So the nice thing about the y's is they already have opposite signs. All I need to do is make them have the same number out front. So if I look at this first equation, I want to turn that 1y into a 5y, which means I have to multiply by 5, because 5 times 1 gets me 5. If I multiply that y by 5, I have to multiply everything in that equation by 5 so that it stays equal. So I'm going to go ahead and rewrite the equation just like before. We're going to do our multiplication. So 5 times 3x is 15x. 5 times y gets us plus 5y. And 5 times 6 gets us 30. Again, we did not change anything about the second equation, so I'm just going to write it how it is. 9x minus 5y equals negative 6. So now we have y's that cancel out because they have the same number out front, 5, but they are opposite signs. One is positive, one is negative, so they can go away. And I can start combining the rest. I'm left with only x's, so now I'm solving for x. So 15x plus 9x gets us 24x, and 30 minus 6 gets us 24. To get x all alone, I just need to divide by 24. That'll go away, and I'm left with x equals 1. So far, so good. We're matching our first time around. So now we need to go and use what we just found, x is 1, and plug that back into one of our original equations to solve for y. This time I'll use the second equation, but like I said, you can use either one and you should get the same answer. So our second equation was 9x minus 5y equals negative 6. I'm going to go back in. Anywhere I see x, I'm going to put 1 and start solving. So 9 times 1 is 9. I'm going to rewrite the rest of it because nothing else has changed. Then I'm going to get y all by itself. So I'm going to do opposite operations. Subtract 9 so that that cancels out. I'm left with negative 5y equals negative 15. If I divide by negative 5 on both sides, I'm going to be left with y equals 3. And look at that. It matches what we got the first time around. X is 1, y is 3. Either way you do that, either by canceling out the x's or by canceling out the y's, you should get the same answer.